You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. A virtual local area network, or VLAN, is a logical grouping of devices within a physical network. It allows network administrators to segment traffic based on function, department, or role without requiring separate physical switches. VLANs help isolate workloads, reduce broadcast traffic, and support network design flexibility. For server environments, configuring and verifying VLAN assignments is an essential skill. The Server Plus certification includes both the conceptual understanding and the practical steps required to implement VLANs. One of the most important benefits of VLANs is their ability to create isolated broadcast domains within a shared network. This is particularly useful in multi-tenant environments where servers perform different roles, such as storage, management, or guest services. By placing each role in its own VLAN, administrators can control traffic flow and prevent unintended access. Server operators must understand how to assign servers to specific VLANs and ensure those configurations match the network infrastructure. VLAN tagging allows Ethernet frames to carry information about which VLAN they belong to. This is done by inserting a 4-byte field into the Ethernet frame using the IEEE 802.1q standard. Network switches use this tag to identify and route traffic within the correct logical segment. The tagged data is not seen or modified by endpoint devices unless the operating system or network driver supports it. Understanding 802.1q is required for managing both physical and virtual networks. Access ports and trunk ports serve different purposes in VLAN configurations. An access port is assigned to a single VLAN and used to connect endpoint devices such as servers or printers. A trunk port is configured to carry multiple VLANs between switches or between a switch and a hypervisor. Trunking is required when a server must participate in more than one VLAN or when it hosts virtual machines on different segments. Properly configuring trunk ports is essential to avoid traffic loss. Assigning a VLAN to a server can be done in multiple ways. The network switch port may be configured to assign a specific VLAN, or the server's operating system may be set to tag its own traffic. In some cases, both the switch and the server must agree on the VLAN ID for traffic to flow properly. Modern network interface cards often support VLAN tagging at the hardware level. Hypervisors and virtual switch configurations also play a role in how VLANs are implemented. To support multiple VLANs from the server side, operating systems must be able to create VLAN interfaces. In Linux, this is done using commands like ip-link or nmcli. Interface names often include the parent device and VLAN ID, such as eth0.10 for VLAN 10. In Windows, administrators use PowerShell commands or network adapter properties to assign VLAN IDs. The Server Plus certification includes hands-on knowledge of creating and managing VLAN interfaces. Verifying VLAN configuration is critical to ensuring that servers are placed in the correct network segment. Administrators use tools such as ping, traceroute, and switch logs to test connectivity. If VLAN IDs are mismatched or trunk ports are misconfigured, traffic will be dropped or routed incorrectly. Troubleshooting often requires coordination between server and network teams. Visibility into switch configuration and port status is necessary to validate successful VLAN deployment. There are several common use cases for VLANs in server networks. Storage traffic, such as ISCSI, may be isolated in its own VLAN to reduce contention and improve performance. Backup operations, management interfaces, and guest access networks are also commonly placed in separate VLANs. These divisions enhance security by limiting access and allow prioritization of traffic based on importance. Proper segmentation leads to more scalable and secure infrastructure. In virtualized environments, VLANs are managed both at the hypervisor level and within virtual machines. Hypervisors include virtual switch components that allow VM-to-VM communication and network isolation. The physical network interface is typically configured as a trunk port to support all required VLANs. Virtual machines are then assigned to specific VLANs using virtual network interface cards. This design provides flexibility and supports multi-tenant configurations on a single host. Administrators often deploy specialized VLANs for voice, management, and guest services. A voice VLAN supports voice over IP traffic and is typically assigned higher quality of service settings to reduce latency. Management VLANs isolate administrative access points, such as console interfaces or BMC ports. Guest VLANs allow restricted internet access for untrusted devices, but prevent those devices from accessing internal systems. These examples highlight the need for VLAN strategy in secure environments. Switch ports must be configured to match server expectations for VLAN assignment. The exact commands used vary by vendor. Cisco, HP, and Juniper each use different syntax and configuration procedures. If the switch port is not correctly set as access or trunk mode, or if the VLAN ID is missing, the server will not be able to communicate. Misconfigured switch ports are one of the most common causes of failed VLAN implementations and must be checked first during troubleshooting. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Understanding the difference between tagging and untagging behavior is critical when troubleshooting VLAN communication. On access ports, switches typically remove or do not expect VLAN tags. On trunk ports, switches add or preserve tags to indicate the correct VLAN for each frame. If a server is configured to tag traffic but is connected to an access port, communication will fail. Documentation of which ports tag or untag is essential to avoid misaligned configurations that can silently drop packets. It is possible to configure multiple VLANs on a single physical network interface by using sub-interfaces or logical adapters. Each sub-interface is associated with a specific VLAN ID and is treated as an independent network connection. This allows one cable to support several logical networks, which reduces cabling and switch port requirements. However, this configuration depends on the network card and operating system supporting VLAN tagging and sub-interface creation. VLAN tags can include priority bits that integrate with quality of service policies. These bits allow switches to recognize traffic that should be prioritized, such as voice or video. Quality of service and VLAN tagging work together to ensure that latency-sensitive traffic is delivered with minimal delay. This is especially important in environments with mixed traffic types or limited bandwidth. Server Plus includes recognizing how VLANs contribute to traffic prioritization and system performance planning. From a security perspective, VLANs provide strong isolation between systems. Devices in one VLAN cannot directly communicate with those in another without an explicit router or firewall policy. This limits lateral movement if a system is compromised. VLANs also support access control lists and network segmentation policies applied at the switch level. When configured properly, VLANs enhance security posture and support compliance with network access restrictions. Monitoring and troubleshooting VLANs requires visibility into both server-side and network-side traffic. Tools like TCP dump and Wireshark allow administrators to inspect frames and verify that VLAN tags are present and correct. Switch port status indicators help confirm link operation and port assignment. Filtering traffic by VLAN ID allows for targeted diagnostics. Administrators must also monitor for broadcast storms or misconfigurations that may affect network performance. Accurate documentation is essential in VLAN management. Network maps should include VLAN identifiers, functional purpose, associated subnets, and the switch ports assigned to each segment. Diagrams help visualize the relationships between segments and confirm isolation. All patch cables and ports should be labeled according to their VLAN assignment. This makes it easier to trace problems and simplifies the onboarding of new staff or systems. After configuring VLANs, administrators must test access to confirm functionality. If inter-VLAN routing is required, the relevant routers or Layer 3 switches must be configured and tested. Testing should include basic connectivity, DHCP lease assignment, and name resolution. Each server should be reachable from authorized peers and unreachable from unauthorized networks. Server Plus includes verifying functional isolation and proper network routing after VLAN deployment. VLANs enable segmentation and security within shared networking infrastructure. By grouping systems logically, administrators can optimize traffic paths, enforce isolation, and simplify troubleshooting. VLANs are a critical tool in modern network design and must be understood at both the switch and server levels. In the next episode, we will cover the concepts of default gateways and routing, including how traffic moves between subnets and across network boundaries. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.